Salutations. You guys might remember this engine. You know how you add oil to your engine so that it lubricates and cools the pistons and bearings? Mine didn't do that, so I get to build it all over again. It's okay though, I was gonna mess with it anyway. You might remember in the last video where I spent an unnecessarily large amount of money modifying cheap turbos, and then got new ones anyway. Well, I get to do that to the engine too. More often than not, you can't just slap a turbo on a car and start running 9s at the strip. But you know that, and when it comes to 454s, you can get away with a lot. But even with that going for you, you still need at least a big ring gap and steel gaskets. Only when I tore the motor I built back down, I found more metal than oil. More accurately, a bearing stew. I'm not sure how this happened, but judging by the bearings, I must have forgotten to clean something. And that something promptly turned my bearings into not bad anymore. Now I picked this engine up back in January. I mean, come on. Who could pass up a $250 454? I mean, who could pass up a $150 454? I couldn't, but my self-control ends where my wallet begins. So you guys know my car. Well, it's been my project since October of 2022. To say it was slow would be the understatement of the century. Glacial, perhaps, is a better term to describe it. It had no power, poor handling, atrocious gas mileage, and more issues than things that worked. Obviously, as an American, I had only one choice. An LS swap. But LSs are overdone. And besides, these big disgusting V8s will destroy the handling of the car. That's if I can even get it to fit. So, about a 2-hour drive there and back at 5 AM to go pick up this engine in a car I borrowed from my parents because I don't have a truck. There it is, with a blown head gasket and a rusty cylinder bore. But if you've seen my videos on Instagram, you'll know how I fix those. 5 months later, I had the engine assembled and running. Until it wasn't. And now we're in the present, where I am disassembling this engine. To start, it gets cleaned a lot, and I will be doing it again. Quite the reoccurring theme in this build. Blown engines are funny and all, but after the first time, it's not funny anymore, and I kind of need this thing to work. Last time the rocker studs came out because I left oil in the threads, so I get to go through all the holes with degreaser and a wire brush. Kind of important when using any sort of thread compound. MLS gaskets are expensive, and needing 2 of them, according to my calculations, might exacerbate this issue. So I went through with the decking process again and was able to get them all under 1/1000th with a 400 grit finish, because that is the precision my straight edge and surface plate are verified to. This being a Mark IV motor means it's the least desirable for performance, and the valves are certainly no exception. They're a cheap 2-piece welded valve that are apparently known to fail even under stock spring rates that'll give you valve float about 1000 RPM before the stock redline. So I figured I might as well replace them with a set of Ferrea stainless valves in the stock size. The heads are washed again because of the decking process and valve grinding compound. I don't want to leave any abrasive material in there. Springs, seals, retainers, and plus 50 thou locks to fit the bigger cam. The taller locks are unfortunately necessary, as GM thought it would be hilarious to give shorter valves to only 2 casting numbers of heads, one of which so happens to be mine, the 781s. The upside being they flow really well and benefit a lot from having a not microscopic cam like the stock one. Once both heads were done, I oiled them up nice and good, and they went back on the shelf. Back during that first engine test, even with a thick SAE 30 on a cold start, my oil pressure was mediocre at best. While I had gone through the bearings back then, and I'll certainly be doing it now, I figured I might as well toss a high volume oil pump in there too. Now the sealed power ductile iron moly coated ring set I'm using wants a 320 grit finish, which is certainly not what the 3-stone hone I was using earlier was. So I have the pleasure of going through each bore with a proper hone. Then again, these ball hones do a much better crosshatch job than the stones, but the stones are the best for cleaning up the bore rust I had earlier. I cleaned the block again and refinished it just so it's nice and pretty for those MLS gaskets, because I'm not buying new ones. You know that oil pressure I was talking about? Well, one of the clearances I didn't check and bearings I didn't replace were the cam bearings. These are fed off of the mains and wear like junk because of the uneven cam loading and can leak a ton of oil. Even though the cam fit pretty snug in the old bearings, after taking them out, they definitely weren't doing too well. Either way, pulling them out lets me clean the block better, so it's definitely good to do it either way. Before I clean the engine, one final time, I wanted to check the lifter bores as I heard they can be too tight even by stock specifications, and sure enough, literally half of them were, which kind of pairs with the funky wear patterns I was seeing on the side of the lifters. I checked them all with a dial bore gauge and then honed them to a closer size to specification. Every oil plug came out, every galley was cleaned with a brush, and every bore with a towel. Once the block was dried, I oiled all important bare iron surfaces so they won't rust till I assemble the engine fully, and sure enough, despite all the scrubbing I did earlier, that crosshatch loves to hold on to hone abrasives. First was to install the new cam bearings with a tool that costs over 10 times what the bearings do that I will only ever use once, just as God intended. Now, not just the bearings were scored. The crankshaft was too, but not nearly to the extent the bearings were. I think the softness of the bearings probably saved my crankshaft from needing machining. I was able to polish it too, while not visual perfection. There was certainly no roughness that I could feel. The main caps were indeed hungry for the oil stew they had aided in making earlier, and I wanted that gone. They got to take a bath in my ultrasonic cleaner with Simple Green, because all the fun chemicals got banned, and all we have is this environmentally friendly stuff that doesn't actually work and costs twice as much. They got oiled and shelved too. The measurements were, well, fine, but pretty big. The mains were sitting at about 4 thousandths of oil clearance. They are consistent and definitely usable, but certainly on the big side. The plastic gauge I used during the first build I think lied to me and said my clearances were pretty tight with normal bearings, so I ordered 1 thou bigger ones to fix it, and now they're too big, but I'm not buying new ones. Next were the rings. They are gapped per bore at roughly 35 thousandths on both the first and second rings. It took me approximately 18 hours to get through them all because most people aren't running even half this clearance. Okay, so I have gapped every single ring here to its bore, and now the grinding process does create some sharp edges, and I noticed that the towel I was using to wipe off the shavings was getting caught on it. Before I install these, I'm also going to be wiping them down again, so I'm going to be using this file going over the edges. After polishing the crankshaft, there's still the sandpaper abrasive and cast iron residue left inside of the oil passages of the crankshaft, so I make sure to clean those out as well. The pistons took the same bath the main caps did, and this is when I checked the rod bearing clearances. They sat at around 3 thousandths vertical and 4 thousandths horizontal, which is pretty normal. I come to find out the number 7 rod is actually 12 10,000ths out of round, where the vertical and horizontal oil clearance numbers are actually swapped, over 6 times the maximum allowed. Funny. Anyway, pistons get their rings installed and they too get shelved until it's time for install. I then checked cranked thrust and it was, sure enough, way too tight. Hardly 1,000th of actual movement. And I say sure enough because I noticed the crank had a little bit of drag on it when it was sitting in the caps. Back out the crank came, and a couple minutes with 400 grit was enough. The rear main seal goes back in with a little bit of RTV on the seal groove and ends, as well as anaerobic sealant under the main cap edge, and the caps are torqued. My clearances were now up to 4.5 thou, which while tight, is still acceptable, and the crankshaft spins easily. With the crank installed, I have the pleasure of installing all 8 pistons. The bores are 2, nicely oiled up, with actual motor oil, not assembly lube this time. I don't know if it's just me, but those highly adjustable spring compressors kinda suck. Only the tapered aluminum ones are really worth using. The rings just kept getting stuck on the block for me. Back to under the engine, I oil the rod bolts and torqued them all twice to make sure the bolts are fully seated. Then I install the oil pump with the ARP pump stud. As you can see, I did the dumb during the first build and used a head bolt by accident on the pump, taking a chunk out of the main cap hole as it was too short. But the cap was fine, so I'm not going to worry about it. The timing set gets installed at top dead center, and then of course my beautiful pink timing cover, already conveniently with a new front seal. I used RTV to seal it, only because I couldn't find the seal I actually bought for this, but that one leaked last time. With the aftermarket harmonic damper I'm using, because I kind of broke the original, I also needed an adjustable timing pointer, and I set it with the deck bridge I had bought with my rod bolt stretch gauge from CCA. Back down to the bottom of the engine, I'm going to install the oil pan with a one-piece silicone anti-crush gasket. I shelled out the money for one of these because I had issues with the multi-piece quart gaskets leaking no matter how much sealant I threw at it or how well I torqued the oil pan bolts. Back up top, I did a final brush of the bolt holes and pop in the new alignment dowel pins with the MLS gaskets pressed into place. These gaskets are paired with a set of ARP 2000 head studs, and I picked studs in particular so when I need to do engine work, my heads aren't at risk of falling off the moment I take the bolts out in the engine bay. That and, of course, the extra clamp load, especially when using steel gaskets, is always welcome. Oil pump intermediate shaft goes in, and the lifters go into their bores extremely smoothly, unlike in the original build, when some of them were slightly sticky. The stock push rods are dropped in too after having taken a bath as well, and I'd wiped down all of my beloved Chinesium stainless rockers, but I'm not going to set preload until it's time to actually fire the engine when I get it in the car. The last intake manifold gaskets I used leaked, and I had to seat the manifold pretty hard to get it to stop. So I'm using the upgraded Fel-Pro gaskets with an outline of hard sealant to hold it in place until the manifold goes in. Now, this is another one of the biggest changes from my last build, being an EFI single plane intake. A single plane isn't exactly ideal for the kind of low RPM use I want, but for some odd reason nobody thought it would be a good idea to produce an intake manifold that aids low-end torque with fuel injection that aids low-end torque. So I'm stuck with a single plane. It's not like tunnel rams for big blocks don't exist though, but the only ones I can find run me more than I spent on the engine thus far. Then goes on the intake elbow I 3D printed out of almost solid PETCF that is heat proof to over 300 degrees. It does a 100 degree turn from the Dominator flange to an LS style throttle body, and it uses an O-ring to seal. It's roughly equivalent in strength to a cast low grade of aluminum and weighs less than half as much. I just have to hope that it's strong enough to handle boost. Now, this piece isn't exactly done yet, but I wanted to seal the motor up while it sits in storage so nothing falls down the intake. These certainly aren't the right style of valve cover gasket to use with bolts instead of studs, but they work just fine with a little bit of sealant to hold them in place. The valve covers were my first real aluminum welding project, and it's also when I learned that pressing the pedal too quickly in AC will make the tungsten explode. For ignition, I'm going to be keeping the HEI distributor because it just makes it a lot more simple for when I'm setting up the fuel injection and I can focus on just getting the fuel done. I know the welds are ugly. It was my first time welding aluminum. And I did a lot of stupid stuff when I was doing it. I'm putting the spark plugs in primarily to plug the cylinders for storage, and these are E3 plugs that I believe are in the middle of the heat range. Typically you'd want to run a cold plug for turbocharged applications, but considering this is a 7.8 to 1 compression ratio that's going to be intercooled, I'm not too worried about detonation. I actually think it would take some amount of effort to get it to detonate. I set the distributor for a safe initial timing of 10 degrees, but I'm still going to check it before I ever fire it. This is just so I can stick the wires on and know it's set roughly in the right position. In hindsight, I probably should have gone for a 45-degree boot instead of a straight plug wire boot, but it still works, and I'm running these with the Protect-A-Boot fiberglass heat shields that I also probably should have gotten the longer ones of. So the thing I hate about this design is that the legs match up, so they want to cross. So it's easy to get it off, because it doesn't need to be perfectly lined up. But when you're getting it on, man, you know, I got lucky that this thing wasn't exactly, well no, it was fully built. I don't remember how I did it. It was probably really sketchy. Yeah, it was. Oh boy, yeah, it failed. Now, I would love to say that's it, but I actually have missed some things. The breathers get capped until it's time to run the motor, and I may have forgotten to install the cam tunnel plug. Also this one oil galley plug. Not a big deal because I wanted to take the flex plate off to clean it anyway. Put it back on and torque it up, and that's it for this build. A bit anticlimactic, I know, but that's the truth behind car projects. I won't get to touch this thing again for another couple months, but it'll look pretty sitting in the corner of my shop until that time comes. Anyway, I hope you enjoyed this video and certainly found it more interesting than the last. I'm still not entirely sure how to go about making these videos and what sort of style I want to use, But I'm sure that's something you don't exactly figure out immediately.